Welcome to this radio channel, and this is another video about propagation. And today we're going to talk about the effects of a geomagnetic storm on shortwave propagation. Now, geomagnetic storms happen because of several factors. First of all, it could be a solar flare. The sun might have a big explosion on its surface, and a cloud of plasma of energetic particles from the sun is ejected, comes towards Earth, and interacts with our magnetic field. Earth has a pretty strong magnetic field, and basically it protects us from the effects of these solar flares, but it also has dramatic effects on Earth itself. Another reason why you can have a geomagnetic storm is not because of flares, but because of something called a coronal hole. A coronal hole is a spot on the sun, or a region of the sun where the magnetic fields are weaker. So what happens is, instead of keeping all the particles from the sun in its sphere, that region where the magnetic field is weak lets out solar wind. And that solar wind sometimes can be strong enough to create a geomagnetic storm on the Earth. Now, geomagnetic storms are in 5 levels. From G1, this is a minor storm, to G5, which is a major storm, and actually even a severe storm. And I can tell you, if you ever have a G5 storm, head outside if the sky is clear. I can bet you that even in a big city you would see aurora borealis pop up in the sky. I've seen G4, G3, G4 magnetic storms actually create auroras here over Montreal in Canada. So what's the effect of that on shortwave? Well, first of all, depending on the strength of the geomagnetic storm, it has little to a lot of effects. Usually you'll see that signals are more wobbly, kind of trembling, because the interaction of the geomagnetic field and the particles from the sun into the ionosphere typically will change in a very rapid way how the ionosphere interacts with the signals, the radio signals. Basically, on a stronger geomagnetic storm where you'll have, for example, aurora borealis like this show up around Earth, especially in the northern latitudes, what's going to happen is very often the east-west signals are much weaker. But it also has an interesting phenomena. Aurora borealis can actually increase north-south signals. So a lot of people, I see a lot of people that just say on the forums, oh, G3 storm tonight. I'm not going to turn on the radio. Why? There's nothing on. Well, you know what? Maybe your favorite station is going to disappear because there's going to be too much absorption on the ionosphere for that. But you know what? It's a great time to DX these very hard to hear low power stations from the south of your position. For example, here, when a big geomagnetic storm hits, I will often go down and listen to all the frequencies from these South American stations that could be in the tropical band, or even in the 6 or 9 megahertz band. And often you'll hear the Brazilians stronger than usual, or you'll hear Guatemala on 4055 Radio Verdad stronger than usual. It does help increase on some paths, and it does seem that north-south is really increased. And an example of that is in strong geomagnetic storms, you'll often not hear all your stations, but if you listen, you'll hear Radio Havana, Cuba coming in, because its south position basically is well placed to still keep a shortwave signal on, even when there's geomagnetic storming. Now, there are some cases, for example, in a very, very severe storm, G4, G5, it is possible that almost all shortwave signals will be just, gone from the bands because of the very strong storming. But never think that because there's a geomagnetic storm, there's nothing on the bands. It's very, very surprising what effects it has sometimes on shortwave signals. But of course, the stronger the geomagnetic storm, the weaker most signals will be, and the more problems will be in propagation for shortwave signals. Um, Geomagnetic storms can appear any time, even in low solar activity, because coronal holes, for example, and even in a very downward, say you're at the minimum of a solar cycle. Well, you know what? I've seen flares at the minimum of the solar cycle. It can happen. And actually, when we look back in time, some of the strongest solar flares ever on the sun were almost always close to the minimum of the solar cycle, which is very interesting. We always think, well, it should be at the maximum, that's where it flares. Actually, at the maximum, the sun will probably flare more often, but will not flare, as I would say the solar flares tend to be, not as strong as a unique little solar flare that just happens at random when a sunspot appears at lower solar activity for some reason. Of course, any time is a time for a major solar flare, and the sun can really pack a very amazing punch to Earth. A great example of that is a great storm that was in 1875, I believe, something like 1875, 76. Don't remember the exact time. And it's called the Carrington event. If you are interested in the subject, just Google the Carrington event, solar flare, and you'll be sent to articles. Basically, one of the strongest solar flares that erupted on the sun in modern times. And it actually, all the workers that were at the telegraph, at the time it was the telegraph, and it was all wired. People working in these offices were actually electrocuted by the high voltages that were induced in the wires. And actually, even some telegraph stations actually caught fire because of it. So, and it is reported that people in the UK, and in New York and London were reading their newspapers without any help of any light because the auroras were just so bright in the sky. Technically, such an event that would happen today would have a tremendously big effect on our technology, and we'd be really going crazy, I can tell you that. So let's hope there's none of that coming soon to our our Earth. But on shortwave propagation, geomagnetic storms can have some interesting effects. And for those that use VHF and UHF signals on very high frequencies, there's something called aurora scatter that basically is a propagation mode that can actually be induced by aurora borealis. If you see auroras in your sky, what you can do is tune in the 2-meter band or the 70 centimeter band of amateur radio in the upper VHF, UHF, and you can be surprised at signals coming in from 1,000 miles away suddenly because of reflection through these auroral zones. And last but not least, when there is geomagnetic activity, even small, any signals that come from the North Pole or the South Pole will be most of the time almost inexistent. They will be absorbed in this phenomenon. So that's geomagnetic storming for you. And you know what? Don't think nothing is on the bands because there's a geomagnetic storm. Tune around. You can be very surprised at what is happening. That is for sure. If you enjoy my videos, why not subscribe to my channel? You'll be informed when new videos are online. If you have any comments, questions, maybe you want to ask a question, something you didn't understand, let me know. I'll be happy to answer. Give us thumbs up if you like the videos, helps us on YouTube. And thank you so much for following me.